So it is recording. So first of all, what is an Arduino? So Arduino is a microcontroller, which just means that it's a device where you can operate different peripherals at the same time. So just means that basically in simple language, it just means that it's a device, for example, like this robot here, which you won't see because of the background. So let me just turn that off. So it's like a robot here. Now the actual Arduino is that component right here. This is a Mega, so it's bigger, a bit wider than the Uno, which you will see, which is the common one, is the Uno, and it's the one you're going to see in the simulation as well. It has a different peripherals. Of course, all the wheels are connected through the peripheral. The battery is connected as well as an ultrasonic sensor, a servo, a Bluetooth module. And there's also an infrared module, and you can even add more components if you want to, which I used to have a speaker on there, but we did remove. So that is what an Arduino is. Now, let's walk first through how you would set up your virtual, or how you set up your Arduino software in the first place. So first of all, I'll show you the steps through the very beginning. So I don't skip any steps, and as such, it will minimize the questions, or at least the confusions that might occur. Of course, you can ask questions at any time. Feel free to just unmute and ask me the question right away. So I will share my Zoom screen here. Here we go. So first of all, you can just open Google. I'm using Chrome. You can use any browser you would like, and we just look out for Arduino. We search down Google. We can go on the Arduino home, or usually you can just find software. But let's say you're not using Google, so you just go in through the website, and then you just go to software, and you would go to downloads. Now, as you can see here, there is a create. I will show you in a second, but just if you guys are in this call, just please follow me because due to maybe according to your internet speed, it might be slow or quick. But this is how it goes. Now, there is a Windows app function. You can use it. For some reason, it never worked for me. It's not really efficient, but you can use it if you would like. Now, so to do that, just press on the Windows app, and it should open on your Windows, on your Microsoft Store. That is if you have Windows. If you have a Mac, you just press on the Mac, and then Linux, of course, you would choose whatever build you have. I would just use the Windows installer. So you just press on the Windows simple. You will receive a screen like this. We're all students. You may decide to contribute later if you want. If you do not want to contribute, which is completely fine, you just press on just download. And then you just wait for download. But as we are waiting and as all of you are doing this, I will show you what Arduino Create is. So Arduino Create is fairly new. It just allows for you to be able to code using online. So you can just code using Chrome. You can watch a simple video here or get to know it better. What you're supposed to do, just select Arduino Create here, or you can just go to create.arduino.cc. You just select web editor and you sign in, which I will be doing right now, if I remember my password, or actually I would prefer signing in with Google. And I just sign in as so, and it would just look something like this. I guess I was working on a Wi-Fi test previously using the Arduino Uno Wi-Fi Rev 2. Which I also have, which I could show you, but it looks very similar to Arduino Uno, so you won't really see a difference. This will look similar to what you will have on the Uno software in terms that you can select your files whenever you want, just open them, and you can start coding right away. There's quite a few examples you can learn from or use and implement on your software. That is simply the only setback up with the Arduino Create is that first of all, you have to have a device plugged in for it to work, which of course that's in link for the software. But if you do not have a device, then Same thing as the software, you can only check your code and just make sure that it is correct. In this case, there is a mistake, and we'll talk about that in later today. That is simply the Arduino editor. Now, I assume it's not too big as a software, so you should have Arduino installed by now. Now, actually, I will share my whole screen to make this a bit easier. So you should have Arduino.
I just had one question.
For sure, go ahead.
So you said we could actually use the Arduino software in VS Code. I downloaded the extension. I was just wondering if we could follow along using VS Code and like
Sure.
how we could set it up.
Yeah. Okay. So this is the setup for Arduino. The first time you open Arduino, it just look like something like this, and it will be blank. I will get to VS Code in a sec. Just give me a sec here. You will have to download a plugin, which is part of the installer as well, which just allows that if you connect your Arduino using the USB, it will be seen. Now, if you don't have an Arduino, you can download it and not now, not plugin, a driver. I think Mac does not require that, and I think Linux does require it, but I do not fully remember off the top of my head. The only other OS system that I've used Arduino with is Linux. So that is what you need for that. Now, how to set it up using VS Code. So for those of you who are familiar with VS Code is, this is what it looks like. As you can see here, that's my code for the interview at Garmin. But first of thing you're going to do is you're going to go to your extensions. You search up for Arduino, which I will do even though I haven't installed. And you just, as you can see, there's a lot of Arduino extensions. Always choose the one that has the most download, and it's also by a reputable source in that case, which is made by Microsoft. You just install it, you make sure that you have it. Now, that means if I open any Arduino file, to open any Arduino file, you just have it. The cool thing about VS Code is it recognizes right away what you're using. And what this allows you to do is it allows you to set up, you don't need a programmer, but you can also set it up using your, so it's pretty much an Arduino full software. So in this case, you can select your board. In this case, I'm going to use the Mega. And the processor, now for the Mega, this is the only time you're going to see this option. Always use it, leave it at Mega 2560. We could talk about that in the end, but we don't really need to know this. And it is set up. Now, serial port, now I don't have anything plugged in yet, so I cannot select anything in this section. Now, this is in VS Code. If you have any questions while you're working through this in VS Code, that's pretty much, you can just follow along as much as you know about VS Code, just type in your text editor here and just select whatever you need here. Now, I might talk about programmer at the end, but that is also not very necessary. Now, let's go back to our Arduino software here. Important things to note. So if you have any updates, as you saw, there is a message that shows updates, but an important thing to note first is you go on tools and then you select your Arduino you're going to use. So in this case, I have my Mega out. So I'll just go search for my board. Now, the Mega is an Arduino AVR board, and there's multiple different ones. Now, the Mega, the different sections here, which also, this is actually quite new. It used to be all in one list, but it really depends on the processor or that's on your device. The AVR boards is the common one. In this case, I'm using a Mega. I also have a Wi-Fi Rev 2. I am getting a Nano every, so I will get to show you all of this. They're quite interesting, usually a big difference in the size. I do have an Arduino Uno Wi-Fi, but it has been discontinued because it is pretty much useless. So this case we selected our board. In this case, as you can see, as you saw in VS Code, There is a processor function. We always keep it at mega 2560. Now, if I plug in the, let's say you don't know what board you have. Okay, plug this in. And just wait a bit. I have to go on port, and then I select the port that I have this plugged in. Now, you don't really need to know what it is. You just select the port. Basically, you always have one if you have one Arduino connected, and it'll tell you what it is. So I select that, and then I can, to make sure that I have the right one, I can just set get board info. Using that, it tells me the name. These three numbers are useless, but you just need the name just to make sure what board you have if you don't know what's it called, and then you just look for the name in whatever you have. Now, if you are getting China, like boards, China knockoffs, you might need to go on Boards Manager and look for your specific library. If you do have one, you can reach out to me later, and we can find out what board you have so you can install it. But it's pretty straightforward. You can just type your board name on the search bar. So for example, if I want to talk about Arduino Wi-Fi, for example, it's all included in the AVR, and the Rev2 is included in the Mega AVR, which I have both downloaded. I think I don't quite remember, but if you download Arduino, I think they only have Arduino AVR boards. Somebody can confirm that, and you can just download the board, the specific more if you have more boards. Now, if you are using the simulation, then you won't really necessarily need to account for anything in the tools. But another important thing in the Arduino is the serial monitor. The serial monitor is basically what allows you to communicate, or what allows the board to communicate with you if there is a wired connection, so if there is a Bluetooth connection. Okay, now we're going back on VS Code really quickly here. Now that I have something connected, I can just, if it lets me do it, okay, so it's not letting me, it's seeing selecting this, which is okay. Okay, so that's interesting. I don't know why it's not letting me do it, but it's okay. I guess we can try and fix that later. But if you have a USB connected, it should allow you should be able to see serial ports as you saw in the Arduino software. But that's okay. You can still use the text editor, especially for simulation processes purposes. You don't need to have the port functional. So this is what we have so far. Okay, now that was a bit about the software, so you can get it set up. Now we'll show you a few things that you might encounter while you're working on Arduino. Of course, the first thing I mentioned is the microcontroller. In this case, I have a Mega. You will also encounter various sensors. So in this box here, I have quite a bunch of sensors. So you might design something that uses either passive or active buzzer. You might design something that uses, I don't know, a mic, a small mic, or maybe a line detector, which actually this robot that I have connected has 3 line detectors. If you want to see it, they are at the bottom here in red. What else? And then there's quite a lot of sensors. Temperature sensor in MPU, which is actually what my research was based on quite significantly throughout the summer, trying to fix that. What else do we have? Various LEDs, and of course, one of the most important things that you will need in Arduino is, of course, the resistors. So I have a ton of resistors in this box. I have quite a lot here. And then I have quite a lot of boxes that have more. You can make quite cool things. If you have a Bluetooth communication, you can make joystick compatibility and just make your robot move a joystick. And we could talk about sensors forever because there's a ton. But this is a few of the things we have now. One of the important things you will also probably need for your project is an LCD screen, which there is a simulation for it in the Tinkercad. And for some of you, you might also need a motion sensor, which looks quite cool actually. It's almost like, I don't know if you can see it, it's almost like a tennis ball or white. Okay, so that is in this box here. There's also a pin pad. And let's see, what else do I have? That could be significant. Another thing will be really important for you or for anybody who works Arduino is, of course, a soldering kit. So I have a soldering kit. I don't know if you guys know what soldering is. If there was still allowed, I would organize a soldering kit, instructions or tutorial at school. But really quickly here, what a soldering kit allows you to do is allows you to fuse metal components using heat. So it uses a rod here that heats up using this device here. You just plug it in, and then you solder. It just this one here. Now you can get two different types of solders. You can get non-leaded or leaded. Of course, leaded is dangerous. If you smell it for too long, you will get crazy. But this is a leaded. You just have to make sure that it's a well-ventilated area. Now the leaded is more appreciated, whether aesthetically because it's more shiny or because it heats up faster. It really depends if you want to use leaded or not. Making sure that you're in a well-ventilated area. And of course, you have the solder holder, which works with the sponge, which is quite dry now. If you were to use it, you would need to make sure that it's wet. Okay, so that's a quick overview of what solder is. And we'll try and organize a session to use hot soldering. Now, this neat tool here is a desoldering, which is not an electric one. So it's mostly worked on with, pressure. So you just, it's like a syringe inside. You activate the pump, and then when you need to desolder something, you heat it up the same way, and you just suck it up by pressing the button. Quite simple, quite useful because you can mess up, and it allows you. If you mess up in solder, of course, you can't take it out by hand, and there's no proper way to take it without a proper desoldering tool, whether you have the electronic one or just using a simple pump-based one. So that is quite important in Arduino because you do work with electronic components, and electronic components is extremely you require soldering. Most boards, especially if you receive knockoff Chinese ones, will not be soldered. So you need a soldering tool for it. This you might see actually throughout university. This is a parallax. There's two different kinds. This is used if you are going into electrical. It's used for your 300 course, which I think is in winter semester. But I don't know what they're going to do with COVID, so you will figure this out. Now, this one has a plug-in feature. You could get a parallax which has the board embedded on there. This one has the board underneath, which is, you won't really see it, but it is in Uno. This is the Uno. This is, in this case, an Uno Wi-Fi Rev 2. The Uno's not inside. That's the one you just saw. But there is a simple Uno right here. This is the most common Arduino you will ever see. I think it's the most sold one too. This is an original Uno, but you will see a lot of knockoff Chinese ones. I have a couple, but I also have real ones, so I might as well show you the real ones. So this is quite simple. It has 5 analog headers, which we already talk about. It has about 13, but 2 cannot be used digital, and it has an A reference, which you don't need. Quite a lot of power components, 2 grounds. So it's a pretty powerful thing for such a small device. The actual controller is right here. This is the core. This is what runs everything. This long one here. Now the new ones are quite small and they're square and non-removable. So if I can remove this, I think I removed it in one of them, but I don't fully remember where it is right now. This is a header. So it is quite popular. This is the parallax one, which is just saw on the robot that I just showed you, but it's not connected. Now all headers are designed to fit through the Arduino. A simple thing that you might need to do for your project is design your own PCB headers, and they just go in through the simple pins, and you just have to align them properly, which of course I won't do it now because I don't want to burn the pins. Okay. What do we have here? Okay, yeah, so I do. So this is the parallax that you also might see throughout university. This is where the controller is embedded. Now, this is not in Arduino. This is made by Parallax itself. So it has a Wi-Fi compatibility. So this is a Wi-Fi module right here. Quite interesting. There's also an SD compatibility, SD card, which I did use for a project, which not this one, but I did use SD cards, which are quite interesting. They require a full lesson by themselves. And so this is real quickly what we have here. Now, there's a lot of different components, smaller components. As you can see, if you saw from the beginning, I have a whole box. I also have an oscilloscope, which you guys might or might not know, in that box as well. And I have other components, which we could talk about in other sessions, which would be a Raspberry Pi and various other things. So Raspberry Pi is it's basically a mini computer. So I have basically, this is the USB-C power, but I have a Raspberry Pi, and they're quite interesting. Now, diving in the simulation world, this is an oscilloscope if you haven't seen one. So I also have one of those. Okay, so now going into the simulation world, I will show you how Tinkercad works. And just before we get there, I just want to show you different sizes. So this is a Nano. This is an Arduino Nano. It has the same power exactly as the Uno you just saw. Much smaller, much smaller. So this is the Uno here, just in size comparison. This one has the exact same as this one, but much smaller. Now this one is used for, I don't know, a lot of people have used their thing. You can remove the pins and use soldering wires on there and make it into a handheld or bracelet or whatever. They're pretty powerful. I think a friend of mine made like a colorful bracelet for his girlfriend. It was quite nice. So you can do quite a lot of things with these things. So the world of Arduinos and microcontrollers is very powerful, very big, and very important to keep in mind. So yeah, so that's important here. Now let's going. Now I think my screen is still shared. So let me show you Tinkercad. Well, actually, before I do it, let me just show you how you get to it. So you can just once again type Tinkercad on Google, and of course it will be the first thing you see. Now, because go on it too much, you pause the link. You just press on that. You will have to. You can follow me as you're doing this. You will have to. Oops, you will have to log in. So you just press on sign in here. I sign in with Google. And just sign in with my personal account. You don't need to link it with an Autodesk account. Tinkercad is part of Autodesk, but it's mostly a 3D modeling. We will use it for our Arduino. So you can skip this. Now, if you do have an Autodesk account, you might as well do it. I do, but I won't do that. And then you can just press continue. And then this is what we have here. Now, you will have to create a new design. Okay. So this is what we have so far. Okay, now you will have to find your Arduino, which I will get to later. If we, let's see. So I'll show you real quick how you do this, or if you can follow along. So you can just press on components, you go under circuits, you will find a section called components. And here, as you can see, there's an Arduino Uno. You just drag it onto the board here. And if you have a mouse, it's better. If you do not, then it will get a bit challenging, especially to turn around here. So you'll just need to use the box that's on the top left. And then we can just start, I don't know, putting in LED, for example. And we will need a breadboard for this. So we can put a breadboard here. And then just, if it allows me to move it. So I'm trying to show you real quickly how this would work. But you can play more around with it and make sure that you connect everything. So to connect things, you just have to make it fit. So you have to zoom in a bit. And there should be, there is quite a lot of things you can see on here, which I don't want to spend too much time on Tinkercad. I will get to it in a second, but I want to start coding in Arduino. So this is how everything works so far. In Tinkercad, just how to set up the main components, and we will get how to code it in a sec. Now let's go back to Arduino, and you can follow along using here. Let's just get a new file. Okay. This is your Arduino, as you can see here. And in my Uno here. So this is what you have for your Arduino. Now, first thing I always recommend is you save, Control S, or go on File Save. If you downloaded Arduino, it will include an Arduino folder under your documents. I could just save that here, and let's call it LED. On, off. Okay, so that's how we called it, LED on off. How you should see this. So I know some of you might have never seen processing before. So let me explain this. Void setup only runs once, okay, as it's implied in the comments. So it only runs once. And then void loop runs repeatedly. Now, in more details, whatever you put in void setup, okay, will run as soon as you press deploy. After it's deployed, so after you upload it onto the Arduino, this will only run the very first time, okay? After that, you will have a loop that keeps running infinitely. It will never stop, okay? So there's quite a lot of things to know about Arduino. But what we should know first is serial. Serial is the communication between Arduino and your computer, okay? Serial in the computer world just means a serial connection could most likely is a USB connection. Most of the time it is. So if you have a USB connection, that's just serial, okay? Does that make sense so far? Okay. When you initialize your serial, you have to start with serial.begin. Now this has to be in the setup because what you're saying is you're just saying that, okay, serial.begin, just start the communication between Arduino and the computer. That's what you're saying. Okay, that's what serial.begins means. It doesn't do anything, you won't see it, but that's what it means. Now the 9600, I would just say memorize it for now, but that is known as the baud rate. The baud rate is how quickly you communicate. 9600 is the most common one and will be available or will work with all Arduino boards. But I think for the Arduino Uno, it goes up. It has a very, very high number. I think it goes to almost 1 million. I don't quite remember off the top of my head, but you can just search on Google baud rate, and you can go on images, and these are the common baud rates that you will see. Now we're using 9600. Now we can just specify it for the Arduino Uno. and we have the maximum baud rate, which is on Wikipedia, should be. But yes, the maximum upgrade we can reach for Arduino Uno was, I think, 1 million. But that's when it causes a bit of issues. But seems like 250K here seems to be the limit. Now you will have to read more about baud rates. A part of my research was also about that. But the most common one we use is 9600, and the other one will be 2400. Okay, so that is important, and that is your serial.begin. Now, let's show a simple command. So serial.begin is the first thing you start with. And then you can go serial.print hello world. Okay, serial.print is hello world. Print is very common in a lot of languages. In C, we print F. In C++, it's print something I can't remember off the top of my head. Processing is also print. And it just means print to something. But in this case, we're saying print to serial. So that means that we want the serial connection to print, or we're telling the Arduino, basically how you should see this. These are codes that will all be uploaded into the Arduino board, right? So by saying serial print, I'm telling the Arduino that send in print to the computer. This is not, even though I'm writing this on the computer, when you upload it to your Arduino, you have to think that this is all on your Arduino board. This is important because you have to remember that if I disconnect this from the computer, it's still on there. That's a cool thing about Arduinos, which is different, for example, other boards, is that the code is non-volatile. It doesn't disappear. So if I plug this in, do that example in a second, you will still have that. So let's say, so that's what we have so far now. I did change my board, but actually let me show you. So let's say I kept this as Mega. Okay, in this case, I'm saying I didn't maybe select the probable port Arduino Uno. And if I upload this, it will get an error. And it will say, give it some time here. Okay, it's usually not that slow. Let's try again. Yep, so that's the error you should get. It just says an error occurred while uploading the sketch. Errors in Arduinos are not the best. They could get quite confusing because you don't know what you're talking about. So you can follow along with the Microsoft the VS Code, and I guess you should have typed the same thing. But this is what you have. So this is the error. Now the most common issue is probably you didn't select your board properly. So we can just say get board info. It says this is an Arduino Uno. So we go here, we go board, we go Arduino AVR, we look for Arduino Uno. Where is it? And it's right the second one here. And then we just make sure and it's set to the proper comms. And then we just press upload. It's a fairly quick process. And so it is done uploading. Now, ignore all of this. The AVR, I think most of you won't have it because I enabled the AVR to print out a lot more programs than you should. I think you can do that through preferences. I don't remember which setting it was, but I guess let's not waste too much time with it. But yeah, so I think if somebody can confirm as well, that would be nice. You don't get these. All you should see, actually, if any of you have an Arduino, which I don't think so, then you will not get any of these. You should just see sketch uses blah blah global something, and then it says done uploading on the very top. Now let me show you how if that code worked or not. So as you remember what I told you earlier, we do have a serial monitor. You can open it through here, or you can just go Tools, Serial Monitor, or just select Control-Shift-M. So I press that, and then it says hello world. So that's your very first code. And the device just produced to you hello world as you wanted it to do. Now let's say I put that under let's comment this. Now comment is just a double /, and I put this here. Serial dot print hello world. Okay, now if one of you guys can unmute and tell me what you think will happen, that would be nice.
It's gonna print hello world infinite times.
Okay, will be on separate lines or will be on the same?
They'll be on separate lines.
Okay, let's try that. It will be on the same line, but I'll show you that. So first of all, always remember to control save, but note something about Arduino, the minute you press upload itself by itself. So, so you have serial.print here, and then we upload it. Now let's see the serial monitor, and you will see hello world on the same line. Now if I just, I cannot stop a serial monitor unless I plug this out, and I don't feel like doing that right now. But something I wanted to remember, if sometimes you open this and you see a bunch of gibberish, so you might see stuff like this, and or you might not see anything at all, which I think if you put a small baud rate, it will do that. So this is data that you can't read, and you're pretty sure that it's right, then most likely your baud rate is incorrect. So just make sure you have the same baud rate that you have. Don't worry about this box here. That is if you're sending messages, which we won't get to today. So it does have it on the same line. Now, if I stop auto scrolling, you will notice that you have hello world stuck together, and that is exactly what you have in your code here. So you have hello world, there's no spaces before or after, and there's only one space in between. Now, let's say you're like, okay, that looks pretty ugly. I want to print it in new lines. There's two ways you can do that in Arduino. Either you say print line ln, which means new line, but backwards. And so that would just put a new line to it. Now, if I press upload, notice that it's saved because the weird squiggly mark, but it disappeared. And if I open the serial monitor, they will all be on a new line by itself. Okay. Now let's say there's another way. Let's say I don't have it that way, and that is what most C coders, if we have any here, would know, and that should be \, which is the button right on top of shift for most keyboards, and I'm just \n, and then you have, and we start the serial monitor here, and it will have no new line as well. Now this reads the spaces, so let's say I do tabs instead, and I upload this. You will see a bunch of spaces. That's because of the tab. Now, I don't know if you can notice it, but the spaces after, it should all be the same. What I'm trying to show you, and I guess I can show you in that example, is the space that you accounted for here is also in the code. So if I remove this, I don't think it will be too clear, but it will be smaller than what you had at the beginning, what you had the first time. So the spaces here are actually smaller by one space. So it's not really clear, but it's there. Just something I want to note. And \t, as I mentioned, is for tab. There's a lot of \ functions out there. I think they're called line endings. You can search up on Google. So that's what we have so far. Okay, now, yeah, so that's the important thing to, well, that's some of the basics. Now, of course, I don't know, did some of you never saw a programming language before? You can type it on the chat or just unmute. So is this anybody's first time programming? I will take that as a no. So everybody has at least programmed once. But so you should be aware that any programming language can do mathematical operations, and you also have an important function called variables. So in this case, you have multiple types of variables. So you have an int, you have float, you have bool, which stands for Boolean. What else do we, and then we have string. Okay. Really quickly here, do any of you know what int stores?
Can you repeat that?
For sure, yeah. Do you guys know what int stores? What kind of, so the int variable, what kind of numbers do they store?
Integers.
Integers, correct. So that means that you will have things like, so I can store an A, I can put, for example, a 5, and that'll work. But let's say I put in a 5.5. Okay, now integers, is 5.5 an integer?
Nope.
Okay. What do you guys think that could happen? What would happen if I print A?
It's just gonna round down, I think.
Okay.
I think that's Python.
Yeah. So let's say I put 5.7. So you guys think would round up or keep it round down?
I think it still rounds down.
Okay. So let's see. So let's upload that to the device. And then let's display it. I do have hello world at the beginning. I apologize about that, but it does round it down. So what it does is it just ignores whatever you have after the point, if that's an integer. Okay, but now let's say I have, for example, let's look at floats now, and I put a float is equal to 5.7. Does any of you know what a float is?
Like a decimal number, essentially.
Perfect. Yep. So that's exactly it. So if I zero print B, what do you guys think it should print?
5.7.
Sorry?
5.7.
Perfect. Yep, that's correct. That's what it should upload. It should be a 5.7. Now, floats are usually rounded to 2 decimal places. We can change them to other things, but we don't necessarily need to know that for this time being. Does any of you know what a bool or a boolean is?
It's a true or false variable.
Perfect. Yep. So Boolean is a true or false variable. Now in processing, Java, Arduino, there is a value known as true and a value known as false. Python has it too, if I remember correctly. C uses numbers. It uses 0 as false or any number as true. So does C++, if I remember off the top of my head. In this case, we're talking about processing. And sorry, not processing. Arduino, and true is a value. So C is equal to true. If we print it, it's not really significant, but it is significant for operations such as if statements or while statements. I'll just show you what it puts. So we just upload that. Something I want to show you guys when it uploads. If I did not press upload. Yeah. So if you press upload on your device, it lights up. Or you won't see it, I think. But it keeps flashing a light until it's done, and then it holds it like right around here. My finger is, my index finger. But you can't really see that. But that's how I know that it finished uploading. If I print all of that, you will just see a 1. A 1 in this case means true, which is how it is printed using the print function. Now, okay, now which one? And now string. Now string, do any of you know what string is? So
just like something that like if you put it around in quotation marks, it just becomes a string.
Perfect. Yeah, so that's exactly it. So a string is anything that is in quotation marks, basically, which just means a combination of characters. A string of cars. That's correct. So Ben, that is correct. A string is a pretty much a group of cars. Which this is spelled incorrectly. So I could say, for example, hello, and store that in a string function, and you would have it as so. Now, note that for strings, you have quotation marks, and I just added a car. A car is only one character, and it's all defined by numbers, which I will show you in a second. So if I have a car, oh, sorry, I already initialized E, and I have E is equal to, I don't know, G. That is by a single quotation. If you do put a double quotation for a character, let's see what happens. It will say it's incorrect. So you do have to put a single quotation for this. And if you do put a single quotation for strings, it will also tell you that's incorrect. Okay, so you have to use the proper symbol for both of them. Okay, and then if we zero print both of these, and then E. Okay, let's say in this case I made a mistake and forgot to put the semicolon at the end. You always end your sentences in semicolons, and I do that. It will show up as an error, and it will tell you there is expected a semicolon before 0. That's something pretty cool about the debugging software of the Arduino. It pretty much knows what most mistakes are in most cases, but in many cases it also does not. Now there's also another mistake, and we could try that again, and it will tell you that it doesn't know what this means. It says here that has no member named print L, and did you mean print L? And that's exactly what I meant. So I just go here and press print L. Uploading that, it flashes, and it's done. Now going back to the serial monitor, and we see everything that we have here. We have hello and G. Okay, so that's about the variables. So that's about the variables and serial. Now, let's say I want to read in input. So let's say, or actually, let's talk about LEDs in that case, because that's what the whole thing in this case is about. So to set up an LED, it's first of all, you need to know what various inputs on the Arduinos are. So as I mentioned, there is digital inputs, there are analog inputs, and the various power inputs. Digital just means it can either be a 1 or a 0. So whatever you can put in here is either a 1 or a 0 of some sort. Analog just means it can receive, different values. That's a pretty crude definition because it's slightly incorrect, but that's for at least beginner level. That's what you could keep in mind for it. Okay, so that is what it is for both of them. Most of the time you will use, depends on the sensor you have. Most likely you can tell right away if you either have a true or false, like in LED, for example. You can just put it on digital. If you have a sensor reading, for example, a flame sensor, which I do have in one of my boards, then you most likely need to use analog because you need to use a certain range of values. Okay, so let's say I would say that a lot of coding is mostly about searching. So let's say you don't know how to set this up, and you're working on your own. You don't know how to write this code. So of course, the Arduino community is full of helpers out there. A lot of people, most likely, if you think of a project, somebody already did it. So we can search on Google, turn LED on Arduino, and that is actually known as the blink example. Very common example, very known. One of the most common examples out there. It even tells you how to set it up. But what we need here and now is the code. So we'll talk about all of these. So you need to know what pin mode is, digital write, delay, digital write, and also delay. So if we go back to our Arduino, first of all, what we need to do is define the pin mode. So the pin mode, in this case, the pin mode is just saying basically, as the name implies, what the mode of the pin would be, which is you're defining the pin that you're going to work with, and the if it's an output or an input. So let's say in this case, just explain really quickly, input or output. Input just means it reads sensor data. Output means it produces a value, either a 1 or a 0. Okay. Now, every board has an LED built in value. In Uno's, it's number 13, if I remember correctly. Yes, it was number 13. It also accounts there is an LED on board, which I actually don't know if, I guess if I'm this close, you can see some LEDs that are on right now. The LED that's orange, that's currently on right here, where I'm pointing with my index, is the LED that we're referring to. There is a small L beside it, and we'll define that as an output. Okay. So now we told the computer, or we told the microcontroller that it is the LED pin is an output, and we now want to describe what we're going to do with it. Now, once again, let's say you don't know how to do it, you just go back in here and you can just copy the code, but it's better if you write it so you understand it. So it is a digital write. Okay. So digital write, and you have to define the pin first. LED pin. Now it's all caps because it is a constant function, which accounts to number 13. And then we have it's either on or off. So we want to turn it on first. Now we delay. Delay, as the name implies, just means wait. But in this case, delay is in microseconds. And then we digital write again. And we turn it off. Okay. If I show you down the board here, and if you just see it on the screen, you'll also get to see when it flashes, when it's done, when it's uploading. I do have a mistake here. And I guess, yes. So I am mixing another thing here, another function. So in this case, we're using high and low for the constants. High just means that you send in a value of 1, which in cases of LEDs just means turns it on. Low just means send in a value of 0, which in this case also means turn off. A high or a 1 just means send in the maximum voltage or the lowest voltage. Okay, that's what it means. So we send in this. And then if you see the LED, it will turn on and turn off right away. So I'm not sure. So it will always look on because there is a slight mistake. So let's say here, as you can see, the LED seems to be on, even though we have a high-low feature or implemented in our code. And it is very common that you need to debug your code. But I want one of you guys to try it. So do you guys know what my mistake is, or what do I need to add or remove? Think about it sequentially. So I'm turning it on in this line here. And then I wait 1,000 or 1 second, 1,000 milliseconds or 1 second. And then I turn it low, and then it loops. So it goes back to the top. And I go high, delay, low, and then it keeps going up forever. Do any of you know what I should add? So it is something I should add. As a hint, you guys know what it should be.
Should you like add a delay in the beginning of your code for 1,000 milliseconds?
Yes, so it could be at the beginning, it could be at the end. Preferably it's added at the end. It does not really matter in this case. because the code will restart to the beginning, but I like putting it after it because it is sequential. So what I'm doing is, or to be able to read it better. So always add comments. It makes things look neater. So you can just say turns. I know it is 6 right now, and you are free to leave if you want. And this will all be recorded, so you can just watch it on the Discord channel later. Yes, you can test it without an Arduino, and I will get to it. You will be using the Tinkercad. But I'm just walking through how to code an Arduino first, and then I'll show you how to use Tinkercad. So turns on LED. Wait 1 second. Turns LED off. Wait 1 second. And then now let's upload it. This. And then you see the LED flashing and turning on, off, and it is a second if you count it. So the code does work, as you can see. Okay. So that is the first code in Arduino you guys have ever written. So you can give a, be happy about yourself. If I guess you don't have partners, but just be happy about yourself. I will show you a code here. It gets a bit more complicated. So this is the example of code I wrote for my robot, quite long. In this case, I have a speaker, I have a flame sensor, and I have a photoresistor. What I want to show you is the setup. So in this case, as you can see, you can have more than one pin mode for all the different pin modes. Here, ENA and NEB are functions that I define as the pin numbers 5, 6, 7, 8, 9, 10, 11. It just means pin 5, 6, 7, 8, 9, 10, 11, as the name implies. If you have a simple number, that is just a digital pin. If it's not a number, if it's not a digital pin, if it's an analog pin, it just has a number, and prior to it has an A. It's that simple. So A0 to A5 on the Uno is what you could use. On the Mega, you have way more. In this case, you have from A0 to A15 and pins 0 to 53, but some of them can't be used. But in Arduino, pins 0 and 1 shouldn't be used. In the Uno, you shouldn't use 0 and 1. They're for communication purposes. Okay, so ignore the other variables we have here for now. And then, as you can note here, they're all outputs. And they're all outputs except for the input for the ultrasonic sensor. The ultrasonic sensor, how it works is it sends in one wave, which is from the trigger pin out, and then it turns on the echo pin and waits for it to come back. And then it's a very simple math. So if I send in a wave and it hits my screen, for example, and then goes back, what you do is you just account the amount of time for the wave to hit and come back. And using simple math, you can just determine the distance. So this is a distance sensor. The ultrasonic sensor is a distance sensor. I'm using E2PROM. E2PROM is a pretty cool thing that you can look into later, or just text me if you want to know more about it. Any data that you store, so all the integers that you have here, dies as soon as there's no power to the Arduino, it dies. It's not there anymore. By using the E2PROM here, or EEPROM, if there's no power to the device, the data that I stored in the E2PROM is still there. So that means that if I store some in there, I can pull it back whenever there's, in this case, I'm doing whenever there's an issue and you lost control, using it just brings it back. Now, if you see digital writes here, the ENA is all for the wheels. So if I turn the wheel, if I turn the wheel, let's say ENA, I think was the top right. So if I turn ENA on, it moves forward. if I turn it, or E and A, no, sorry. How this works is E and A controls left, and E and B controls both wheels on the right. And then N1, N2, N3, and 4 is for separate wheels. So there's one for 2 wheels at a time and one for separate wheels. I didn't make the configuration for the wheels. Whoever manufactures them made it that way. So you have to follow what they say. So you have to turn ENA on before you can, in this case, before you can choose control the separate wheel. But in this case, low just means turn the wheel off, so it stops moving. High just means you turn it on. Some sensors, like the wheels, accept both analog and digital input. In this case, I'm all using digital, but if you put analog, I can set speeds. So by setting speeds, I can just make it go at a certain speed instead of going high, which goes max speed, or low, which goes lowest speed. To set inputs using analog, it's just a simple function. And you could use digital write or analog write. Analog write would write whatever value you want. First, you put the pin number. So in this case, let's say we use A0. I don't have an analog sensor in my current reach. Well, actually, no, I think I have a Lux sensor, but I could show you later. So Lux sensor is the light sensor. So let's say I had analog write A0, or most likely it was analog sensors. You most likely would read. Read A0, and so if you read, you don't really need anything except read, and we could store the value in, let's say, float. So that is a proper way to read an analog. And then if I have string, sorry, no, I can do serial, the initialize serial, yes, serial dot print ln b. Or I could combine all of that and have serial print ln and that would also work. So make sure you have the proper brackets. If we have time, I will set up a Lux sensor and I will show you that this does work. But that just means that I said that there is a sensor at A0, which of course I have nothing right now. And it is reading whatever sensor I have, in this case it will be a light sensor or a photo resistor, which is also a different type of light sensor. Does that make sense so far? That's the basics you need to remember in Arduino. Very much having these basics is pretty much, if you know these basics, you can pretty much code most things in Arduino. You might not know what E squared P ROM yet, but you can search it up. Yeah, so pretty much knowing these basics, you could pretty much do this mapping futures I have, which is a very long code. Mapping futures, what it does real quickly, if you guys want to know, it's a robot that starts at a position. You give it a certain position, X and Y coordinate, and then it moves to that position while it's going. In this case, while it's going, it's storing values for sensors. In this case, I'm storing values for photo sensor and a photoresistor, flame sensor and a photoresistor. So if there's heat or fire along any way, it records that at a certain value threshold. And a photoresistor is also light. So when it's dark or there's light, it records that, and it just keeps track of all of that along the way. So it's a pretty neat code. If any of you are taking, I think it was ENEL 301 in winter semester, you will not see it this year, but you will, actually, so none of you will see it, but the people of next year might see it. And if they take ENEL 301 this year, the course will be a bit different. So that's what it is so far. Now to Tinkercad. I haven't used Tinkercad for a while now. So I'm trying to fully remember everything that works while we're working through it. So let's see. Oops. Okay. So first of all, we add all the components we need. Okay. Now, this is a breadboard. If you guys are aware how breadboard, or if you all have aware how breadboard works, it's every horizontal line here is connected on one node, while every vertical line after the red line is connected on one node. So in this case, all of this here and the one beside it are two different nodes, but all along through here. And in this case, you have all the horizontal lines before the ridge are all on one, and then you have the exact same on the other side. So you can have quite a lot of connections in a breadboard. Now, so let's see. Okay. So this is harder without a mouse. Um, okay. So it's not letting me edit. Interesting. So I don't know if it works on some of you, but if you right click, you should be able to see a bunch of settings, which allows you to, one of them will allow you to change the code on the Arduino. For some reason, it's not allowing me. So if it works with someone, let me know, and then we can just assist you from your computer. How are you guys doing so far? Okay, well, I get this to work. It is 6:12 again, as I mentioned. If you need to go, you can go. But I guess we can alter something here. So what I could do is I will get Tinkercad to work. Just give me a few seconds here. What I need you to do, or what you could do, is I'll give you a small activity. If you are able to finish it in the next, let's say, 20 minutes or so, or 10 to 20 minutes, then we will upload it to the Tinkercad and show you how it works. What I want you to do, if you can see how servo motor works, I want you to be able to power an LED at a certain sequence. So as you saw that we did in our LED example here, and have that to work. And I want also to servo, to control the servo to move at a certain angle, and also and it just repeats it every loop. Something I need to note that you will need to do is you probably will need to yes, it will be, as I mentioned, the recording will be sent as a YouTube file and will be as a YouTube video, and will be sent on the Discord. What you might need to do for your servo is you might need to download new libraries, which is quite common, So you just go on Tools, Manage Libraries, and then you can search. After searching online, of course, you can search for whatever library you need, which you can also search right away. And in this case, you might look for servo, and there is a servo library built. It's a built-in right now, so I guess you don't need to download it. But just keep in note that you might need to download other libraries out there that you might, throughout your Arduino experience. So yeah, that's something else I wanted to note, that just how to download libraries. And while I get Tinkercad to work, if you guys could do that, that would be great.
Sorry, I wasn't here for when you said we should do something. What did you say? If you could just repeat what you said
Yeah,
before
for
that.
sure. So I just want you to write a code that will have the LED blink on and off every couple of seconds of your choice, and the servo to also turn at a certain angle every couple of seconds as well. I
Okay.
haven't went through the servo yet, but it is. So what you should do is probably look online and see how a servo works and use that to be able to code it, which is quite common in the Arduino world.
Mhm.
Sorry. So I have my Tinkercad and my Arduino code up. Where do you click on the Tinkercad to have have the code go to the Tinkercad, for lack of a better word?
Yeah, for sure. So I did do a slight mistake in explaining how the Tinkercad works. So I will get to it, let's say, in a minute or so. And yeah, so I got Tinkercad to work. I just did a slight mistake at the beginning. So that's why we couldn't make it work. I will show you. Okay. So I will share my screen once more, and I will show you how Tinkercad works. Yeah. So if we just go back on Google here and we go Tinkercad, and then we go select website. The mistake that I did, and because I didn't realize this at the beginning, you have to go on circuits, and then you go create a new circuit. So you have to make sure it's select circuit, and then that's where you can select your Arduino. Just click on it, or you can drag it, and then you can start code. And what Tinkercad has is you can code using blocks. Now, I don't like that. It's Unreal coding. You can if you want to, but I would prefer that you use the text method, and you will see exactly what we saw in the Arduino. Now, what I usually like to do is I code it in the Arduino because it has a better debugging feature. Using that, and then after you verify whatever you're doing, and it gives you done compiling and it's good, you can just take that and put it here. Now, I do think the built-in functions work. We'll see. So after you have your code and you put in here, you can just press start simulation. And as you can see, the LED here, right here, turns on and off as expected. As I mentioned, this does not have everything you need. So what I mean by that, it only has an Arduino Uno. It doesn't have all the sensors you might encounter, but it is a very powerful simulation and has a lot of what you might see. So this is some of the things you'll see. What else? Yeah, so that is, I would prefer that you code in text, as I mentioned. You can make quite a lot of circuits in here. So let's say, oops, or something I want to mention as well is you have a serial monitor at the bottom here. And if I just extend this a bit further, in this case, because there's nothing in analog A0, it pretty much produces a lot of random codes. And if I do start simulation again, you will see it. So because there's A0 is usually used for the random number generator. So A0 is built in to have a lot of random values in there. And that's why it's common to see a bunch of weird things. Now, as you can notice here, it's quite slow. Simulation is quite slow. It's not quick enough, at least for some application that you'll need. But it does, allow you to code Arduino while you're at home. So that's good. I think it doesn't have an E squared PROM, but you could try that. Enabled. And, oops. So that is a few things. What else would you need? And then we can turn off code and add in a few things here. So we can search the servo, and then we can connect it to oops. Something I didn't know is apparently Tinkercad has built-in functions in here, as you can see. So that is interesting. So I guess that means that you can build a lot of, there's a lot of starters here. You can, it has already pre-built or pre-designed values that you can just use. Common one you might need is the breadboard, but it's quite simple to use, and it's quite fairly simple. Just while we're at it, I'll show you how the breadboard works while you're working. Oops. Just delete this. Let's say we want to keep our micro servo here. How this works is all of this node here has a constant positive, which is connected to the other positive here, and the other one's negative. Now, to do any circuit, you always have to complete it. So let's put our, let's say we put our ground right here, and then I'll put our power right here, and then we put our signal right on the board. And then let's say I also want to put an LED. Now an LED always requires a resistor. Does everybody have it so far yet? So I will walk through it, and you can double check what you have, and just follow along. So first thing, it is nice to always have somebody message. Okay. And let's see here. So print. Serial dot begin at baud rate 9600. And then does anybody want to continue this? What would I do next?
Would you write pin mode?
Correct. That's exactly what I would do. And yep, so we would write pin mode, LED built in. Good. Okay. And what would we set it as? Would it be in output or would it be in input?
I think you'd set it as output.
Yep. That is correct. And then would we have another pin mode?
Oh,
So let's say we don't know how Servo works. We could just go on Servo Arduino, simple and critical, and we go our Servo Arduino reference. You could read all of this if you want to, but let's say just want to use a simple code, which try and select the first one, and then Arduino. If it's on the Arduino website, it always gives you a simple code. Simple code. So how Servo works, it doesn't use pin mode to get attached. Basically, it uses its own library function called attach. Now, this is how you initialize it. So you have to include at the beginning, include the library for Servo. And if you don't have the library and you press upload, it will tell you, do you want to download the library? So you just do that. But it seems like I just checked. It seems like it's built in now, so you don't need to download it. And then you can, you're starting a Servo, is a Servo class, and you want to have an object of it, and you can call it whatever you want. In this case, they call it my Servo. In our case, we could call it our Servo, just to show you that can be anything. Okay. After that, that's basically what you use each time you want to use the Servo. So that name here. So in this case, we would attach it, which means just telling the attach just means tells the Arduino that there is something attached or a peripheral attached to you. Just That's what it's saying. That's why it's only ran once, and that is in the setup. And then just to call any function or any method on the object, we just go dot our servo dot attach, open bracket, and we want to put the pin number, which in Tinkercad, which is I put it as 8. Now I put it on 8 for a reason, but if you guys think it should be something different, let me know. Let's say I put it on 8. Okay. And so that is how we connect our servo. Now, let's say once again, you're sitting there like, okay, what do I do next? We can go back on our servo library. Is this servo? Which one is this? I can't tell because the oh, here we go. So I just search it again. Arduino servo. And let's go here. So this is the servo. We have to include servo.h. Now, I would recommend, instead of actually looking at the methods, look at one of the examples and try to, see how much you can learn from it. So let's say we select the first one and just go search for the code, and it will pop up in a second. So we have it here. So first of all, we have include hashtag servo. They created an object, a servo object control servo, as we mentioned. These are just variables. We don't really need to, can do it that way. So, or you might not. It doesn't really matter. But then we attach the servo. He attaches it at 9. The servo runs on various inputs. Or actually, I won't go into the details of this, but you can attach it at a PWM channel. And then he stores the value of whatever he reads from the pot bin. And then he scales it, which I don't fully, I think, oh, I see what he's doing. I think I understand what he's doing. So, okay. So apparently he has a pot pin, which a pot pin is, I think I have one of those. But that is just, the pin that you just twist on, which is, pretty much a variable resistor. But you can, it's a knob. When you set knobs for volume controls, for example, on your speaker, that's exactly what, or that's similar to what a pot pin is. Okay, so it's a potentiometer. So he reads the value of that, and then you have to map it, because you have to know one thing about servos, and that they only run from the value of 0 to 180, which is simply degrees. It makes sense. It goes from 0 degrees to 180 degrees. Okay, it's quite simple. And then the important one that we need here is my servo to write, and you write the value. Now, because what I asked you guys is just make it, if it goes to a certain value at a certain time, we can just go my dot servo. Oops, that's not what we called it. We called it our servo dot write, and we could say it starts at 0, delay for a second, and then go our servo write to 180. Oh, and that's completely wrong. Right to 180, and then delay for. Does that make sense, or does anybody have any questions? Okay, so I'll take. Okay, so I assume everybody understands, but am I done? Is there something I need to add? Okay, so I'm not done. Does anybody want to tell me what I need to add?
The code for the LED blink.
Perfect. So where would I add that? And what would I write?
So you do the I think it was digital right under the loop, and you want it to blink so every 1 second. So digital right and then LED high. I don't know. I got what you kind of said.
Yep, that's good so far. So yeah, you would use digital right, but would I write it here or underneath?
So it'd be underneath the servo code because you want the servo to go first, or the LED to go first, and then the servo to follow up. Thing.
Okay, sure. Yeah, if that's how you understood, that's good. But just to make sure, so you're saying that you want the servo to go first and then the LED. How I was imagining it is they both go at the same time, but that also works. So you can just say digital right. What do I write then?
LED and then high for on.
Yeah, you specify the pin first, and it is specifies LED built in, and then you go high, correct? And then what do I do next?
You're going to delay it by 1,000, so it's going to be 1 second.
Yep.
And then you're going to digital write it again for LED built in low, so it's going to turn off, and then you're going to delay it again by a second.
Perfect. So yeah, and then what we do next is we check. Now, if you do press check or upload, it saves it automatically. There is a slight error, and do you guys see it? Why?
Because of the semicolon.
Perfect. Yeah, so that's exactly it. So we just add a semicolon here. And we press check one more time. And we're done. So then I just take all of this, copy it, go to Tinkercad, go here, Control A, Control V, and then just double checking a few things. So we attach it on 8, that will be built in as 13. And then we just start simulation. And okay. There's one thing I want you to notice. When this reaches 0, it doesn't seem like it's waiting for a second. Can somebody guess why is that the reason? So if you look at it, it reaches to one side and then goes back right away to 180 for the servo. Does anybody know why or can guess why? There's no wrong answer, so you can guess.
Is it because it starts the delay once the like the rotation starts? Is that why?
Perfect. That's exactly it. So what the digital write, or in this case, our servo write does, it sends in an input. Now it doesn't wait till the input has been perceived or not by the peripheral. It doesn't know. The peripheral does its own thing, right? So what it does is, yes, the minute it sends the input of 1, or in this case, it sends in of 0 degrees, for example, it goes to 0 degrees. And then it just, and then, so send in the value, okay, go to 180 degrees, and then just starts the delay right away, okay? So that's exactly it. That's the reason. If you do want to wait for a second, if you see here, it takes about 1 full second to go to the other side. So if you wanted it to seem that looks to 1 second, what do you think we have to do?
So delay 2,000 then?
Perfect. So would be in this delay or that delay, or both. You can take a guess. Or we could try both, we could try your guess and see.
So I think it'd be the one after.
After which one?
Oh, so I think it'd be the one after 0.
The one after 0. Okay. Oh, sorry. You have to stop simulation first, and then do that, and then start simulation. So it is correct. Now it's not 1 second because we don't know the full time it takes to go that way, but the reasoning to put it after y to 0 is because yes, it takes 1 second to move that way, and you just want to wait for a second between the first write and the second write of the servo, and after that you don't really care how much time it goes because you now think about the LED. In this case, I'm not fully sure, but I think the LED light is reversed. So it turns on when it should be when you say low, and it turns off when you say high. The case for that, I'm not 100% sure why it does that. Now the LED on the board seems to be correct, but the LED on the breadboard seems to be reversed. Not fully. Well, actually, I think I know why. Yes, because I connected the resistor to a positive. So that means that it always has current going through. And the only time it won't go through if this is reversed. So there is a reason why. And I guess if you didn't fully understand that, I'll keep that to you to think about it more. But there is a reason why it's reversed. And I guess that does conclude what I want to go through. Sorry for going over time. It's a bit different when you have to use a simulation. But that's what it is so far. And does anybody have any questions?
I have a question.
For sure.
In the code, why do you write my servo dot write 0? What's the significance of the 0?
Yeah, so in a servo, the input that it receives is degrees. So it is the degree of I don't have, I'm using my current servo on the device, on my robot here, but this is 90 degrees. This is 0 degrees in that case, and this is 180 degrees. Okay? So how the servo works is if I say write 0, it goes to 0 degrees. And then if I say go to 180, it goes to 180 degrees. That's how I'm coding it. If you want to see that code on a real device, here, I'll show you. But does that answer your question? Did I not capture it properly?
Yeah, thank you.
No problem. While I write it for this code here, does anybody else have any, for this robot here, does anybody else have any questions?
Shouldn't it be 2000 for the delay for both of them for the servos? Just because it does take like when it's in a loop, right? It's gonna do both motion forward and backwards to 0 and 180.
That's a very good point. Now, we put 2000 here because it looks to our eyes that it takes like 1 second rest between both. Now, I didn't put a 2000 on the second one because yes, you're right. It will take about a second to go through here, but you won't see it on the servo, but you will notice that the LED acts quicker. The idea of the 2000 and 1000 is just a bunch of numbers that you put to make it seem like you want to get it to work your way. If I do put 2000 here, then you will see that when it reaches this, it waits about 1 second before the LED inputs change. And we could also implement that. That's the only difference between what I have and what you're suggesting. Does that make sense?
Yeah, because I thought we were just like supposed to like make it wait 1 second after it turns and then turns on the light, or that's like what was intended.
My intention was to make both work at the same time. So sorry if I didn't explain it properly
Oh,
at
yeah.
the beginning.
No
But,
problem. No problem. Thank you.
But the only, just to note, if you do wanted to make both work at the same time, then it's just as simple. Or actually, can somebody guess what you have to do? If you want them to both, turn on the LED and turn at the same time.
You just put them in the same like at the same time before putting the delay. Like instead of having 4 delays, have 2 delays, and then stack them together, I guess.
That's exactly it. Yeah, it's quite simple. thing is about coding, yes, the language might seem hard, but it's the minute you get the language, what gets you into, for example, Garmin, is if you can think logically, if you can, be able to understand the input you're going at. That's why, for example, if you want to work for Google, Garmin, any of the software companies, they will tell you put in any language of your choice. They'll give you like an activity and put in any language of your choice, because learning the language is not the hard part. It's just the logic behind it. So if I do that and I make both of them work at the same time, you will see that they both work at the same time as you suggested.
Thank you.
No problem. Does anybody else have any questions? No problem. Yeah, that's interesting. So thank you for attending today. I hope you guys have a wonderful day. And yep, so there is a small issue with my Arduino here, which is okay. But if you guys have any final questions, then I'm still here. If you don't have any more questions, then you're free to go. And as I mentioned, this will be uploaded on YouTube and will be sent as a link to the Discord. So thank you all for attending, and thank you. I hope this was useful to you, and I hope you have a great night. Okay, I will stop recording.